Hi there. Welcome to week 3. Let's look at our business case and problem statement for this week. Our clients have reported raw material costs varying 40% across its Asian suppliers. They suspect inconsistent quality reporting. Our expected deliverable is a cost quality matrix visualization. So let's take a look at this. Let's say our clients buys materials from different suppliers. Some are cheap, but the quality is bad. Others are great, but way too expensive. How do we know which supplier to keep and which to let go? That's what we'll be learning today. We are going to use this simple grid to compare suppliers. On the bottom here, we have cost. Cheap on the left, expensive to the right. On the side, we have quality. Bad at the bottom, great at the top. So this splits suppliers into 4 groups. On the top left, we have the best value or best deal. That is, they are at the low cost quadrant and at the high quality quadrant. At the top right, we have expensive but good, and we call them cost risk because they are expensive, but the product are good, right? Because they are the high cost quadrant and the high quality quadrant. On the bottom left, we have cheap but risky because they are the low cost quadrant and the low quality quadrant. So this area here, we have cheap products but poor quality. Then at the bottom right, we have high cost but low quality. They are risky because the cost is high because they are the high cost quadrant, but they are also at the low quality quadrant. This makes it risky. And for us, we have to ask our clients to reevaluate these suppliers. Now, for those in this quadrant, we can ask our clients to negotiate because they have high quality, but the cost is high as well. For these suppliers here, we can ask our clients to purchase from them because they are at the low cost quadrant, but their product have high qualities. This matrix is widely used in supplier evaluation and procurement strategy, especially in manufacturing and retail. It balances cost efficiency with product service quality, directly aligning with our clients' procurement needs. So learning how to apply a cost quality matrix using Excel and real business data, you are developing the mindset of a strategic data analyst, not just someone who builds dashboards, but someone who drives smart sourcing, reduce risk, and saves companies millions. So let us go into module 1, which will be data preparation with Power Query. We will be preparing our data with Power Query. The objective here is to transform 4 scattered data sets into one unified, clean analytical table that we will use for our metric design and dashboard reporting. Let's get to our data set. We will go to data and we'll click on get data from file because we already know how our data is saved. We have 4 tables. The first will be supplier costs, which is a CSV file. So we'll say from text to CSV. So we'll now pick our supplier costs and say import. So let's click on transform to take this to Power Query. Now we have this in Power Query, right? Our supplier cost is here already. So what we will do is to make sure that we can bring other tables to Power Query. So to do so, we'll click on home. Then I'll come to new query and I'll say I want a new source. I click the drop down on new source. I click on file and we still have another CSV, right? So click on CSV and there we have material taxonomy. a CSV file to bring in. So I'll click on that. I'll say import to import here. So I'll just click OK because this is from Power Query itself. So I have material taxonomy here. Then let me bring others. Click on Home, New Source again, and we have our quality metrics, an Excel file. So we'll say from File, Excel Workbook. We have our quality metrics in the same folder. So click on Quality Metrics and click on Import. I'm going to check this sheet because that is what holds our quality metrics. Then click on OK. So we have our quality metrics, but because it came through an Excel file with a sheet named as sheet 1, we have to rename this query to quality metrics. Quality metrics, hit enter. So we have our quality metrics now. So we have one file left, which will be the supplier location. It's a JSON file. So let's click on Home, click New Source. It's a file and a JSON file. Click on JSON, and then we will select our supplier location and click on Import. Okay, so we have something to do here for the supplier location because it's a list. So we will click on this transform to convert that to a table. We click to a table, okay? So then we go ahead and just click OK. It's now a table, but we have to expand this because there are more columns within this. So click the expand button, and we definitely want the city, country, latitude, longitude, as well as the supplier ID from which we will be merging. It says list may be incomplete, so click on load more. We have it completely loaded. We want all of these columns, right? The supplier ID, the city, the country, the latitude, and longitude. Let's uncheck use original column name as prefix. We don't want the original column name as prefix. We uncheck that and we click OK. Once we do that, we now have everything we had within that table, okay? All right, this is complete. We have successfully imported our supplier cost, our material taxonomy, our quality metrics, and our supplier location, okay? While looking at our data, we have to make sure that we pay attention to some anomalies or to anomalies. If you look at this material taxonomy table, you'll find out that it loaded the columns or the table without the column names. Instead, the first row here should have been the column names, okay? So what you will do in such situations is to convert this first row to the column names. And to do that, you go to Home and you can see use first row as headers. Click on that. It's going to convert our previous first rows to our new headers. Okay, so now that that is done, we will move to the next step, which will be to merge our data set. To merge our data set, we'll go to Home. To merge our data set, let's go to the primary query, which is supplier cost. While in the primary query, let's go to Home and now click on Merge Query, okay? And we want to merge our material taxonomy table, right? So pick material taxonomy. So here we have columns that are related. We are going to leave the left outer join as the join kind, okay? So I'm going to pick material type from our supplier cost table and also pick the material type from our material taxonomy table. You can see that the selection matches 100 of 100 rows from the first table. So we can go ahead now and click OK. Now that we have done this, we need to expand this material taxonomy table to become part of our supplier cost table. To do so, we will click the expand button here. If you look at this now, we already have material type on the supplier cost table, right? So if we allow material type to be added to this table, it will be a duplication of columns. So what we'll do is that we'll deselect all. We just want material group and processing stage because we had material type in our supplier cost table, right? So go ahead and click OK. So we, instead of adding 3 columns, we added 2 columns from our material taxonomy table, okay? So material group and processing stage because we already have material types here. The next merge will be our supplier cost with our supplier location. All right. So still we are using the supplier cost query as the primary query. So we are going to go to home, now merge queries. Okay. Then we pick the supplier location as the secondary table. Now, if you look at this table, both of them, there is one column that is similar to both of them that they have in common. That is a supplier ID, right? And a supplier ID. So we have the match, okay? We click OK. As we did earlier, we have to what? Expand this, okay? We click to expand. We already have supplier ID, so we wouldn't want to pick supplier ID. So we'll deselect all and just select city, country, latitude, and longitude. That will be fine. So click OK to expand that to join here. While on these merge queries, while we were merging the queries, you will see that we have 2000 instead of 100 now. So that created some duplicates. If you look at this, you see that this city is the same, the country is the same, the latitude the same, the longitude the same. If you go down, you are going to see the supplier the same. You have some high-level duplications here. That is with the same product, the same unit price, the same volume, the same material processing, the same material group rather, and the same processing stage. So we have some duplicates here, which we will have to remove, okay? So the last merging will be to merge quality metrics. So let's go still in our supplier cost table. Let us go to home and merge queries. We want to use our supplier cost as primary table, then our quality metrics as the secondary table. We are using left outer join, okay? We are going to be joining using our supplier ID from the primary table and our supplier ID from the secondary table. You see, this selection or the selection matches 2000 of 2000 rows from the first table. Like I say, this just shows us that we have lots of duplicates, right? Because it's meant to be 100 of 100. So we will deal with the duplicates, okay? So click OK, and let us expand this as well. Click the expand button. We already have supplier ID. All we need from the quality metrics table is the defect rate, compliance score, and the delivery time, okay? So we deselect all and just check these three that we need. Always make sure, even though mine is not checked here, always make sure to look at this so that you uncheck it, okay? So click OK, and we've added that, the defect rate, the compliance score, and the delivery time in days, okay? So now that we have done that, we need to actually handle duplicate entries. So we will use our supplier ID column to remove duplicates, okay? So we'll go to home, under reduce rows, click the drop down on remove rows, and let's remove duplicates. So duplicates have been removed, and we have unique entries for 100 rows. And you can see that we have all the columns that we need. You can double check the data types to ensure that you don't have any issue while performing your analysis. So now that we have done that, we need to rename this query. So let us name this query supplier performance. Okay, so let's change this to supplier performance. All right, now, so we have cleaned these, merged our tables, and renamed our query now to supplier performance. These have successfully satisfied our objective for this module. So let's go on to the next module. Come to this module where we will be designing our metrics. To successfully design our metrics, we need to add new columns. I'll be adding those columns here in Power Query. So the columns that we'll be adding will help us to create fair, comparable performance metrics for suppliers. So we want to know how much they charge, how reliable they are, how timely they deliver, and how compliant they are. These metrics will help us compare all suppliers fairly regardless of size or product. So the first column we'll be adding is the weighted cost. We will need to calculate the weighted cost because not all suppliers deliver the same amount. A supplier who sells more has bigger cost impact, right? Okay, so let's go ahead and do that. We will be adding that column to our supplier performance, right? So let us go ahead and do that. So we'll click on add column, then click on custom column. In this custom column, the name will be cost volume, right? So let's give it a new name. We'll say cost volume. We have volume here. We have the cost column here. So what we'll be doing here is that we want to multiply our cost with our volume, okay? So that's what we want to do. So this is going to help us actually calculate our weighted cost, which will be a new column we'll add after this, okay? We said equals here. We want to multiply our costs, double click to enter this, our cost per unit column by our volume column. You see, we want to multiply cost per unit by volume. So we'll say cost per unit multiplied by volume. We click OK, and this calculates our cost volume. All right, now that we have added our cost volume, this cost volume will be instrumental in calculating our weighted cost. So now that you have added it, remember to always rename your step, because this name is going to be instrumental in helping us calculate our weighted cost as well, because we need to refer to this step that we've added. So let us right click on this, rename this to added cost volume, hit enter. So we have renamed that step. So this step will help us in our formula, okay? So let us add that column, which will be our weighted cost column. We'll click on add column, click on custom column, then the custom column name will be weighted cost. So we are going to impute the following formula. We'll say list dot sum, open parentheses, hash, open quote. Now we want to refer to our previous step, which we rename, right? Added cost volume. And this previous step was the step added when we added our cost volume, isn't it? So we will say added cost volume. Then here now, we want to now refer to the cost volume column, okay? We'll look for the cost volume, double click to enter into our formula. Then we will close our parentheses and then say divide lists.sum, open parentheses, still referencing this previous step, hash, open quote, and we'll say added costs volume, okay? Now, let us now refer to our volume per kg, right? Let's refer to our volume per kg, this column. We'll double click to enter into our formula. Then we close our parentheses. You see that we do not have any syntax error. So what does this formula do? The list.sum here converts the outcome of this into a list and sums it. The added cost volume here, remember I said, is the previous step, right? Then the cost volume here is the product of costs and volume. Remember when we did that? So what this formula does really is a summation of cost times volume divided by volume, right? So this is like the summation of cost times volume. This first list is a summation of cost times volume, because you know this is cost times volume already, isn't it? Divided by volume. I don't know if that is clear. Cost volume is cost multiplied by volume, remember. So list the sum, sums or converts this to a list and sums it. So it's like we have one value. We now divide it by volume. Okay, that is what happens here. We click OK. We are going to have our weighted costs column now. Okay, so let's rename this to added weighted cost and hit enter. So the next thing we have to do is to convert the weighted cost data type to decimal. Okay. Let us calculate delivery timeliness index. The delivery timeliness index measures on-time delivery as less than or equal to 7 days and penalizes suppliers that supply outside 7 days buffer delivery time. The index measures how quickly deliveries arrive, with 7 days as on-time threshold. Then the formula dynamically penalizes delays while ensuring scores stay within a standardized 0 to 1 range. Because of minimizing the length of the video, a document with a detailed explanation is attached to the description so that you'll be able to understand what each part of the formula does and how it can be achieved. Okay, so let us go ahead and insert or add a delivery timeliness index column. So we will say add column, click on custom column, and we'll name this column delivery timeliness index. So let us input this formula. Okay, number dot round down list dot max. So this now will help us calculate our delivery timeliness index. We click OK. We now have our timeliness or delivery timeliness index. You can see that those who delivered in 5 days have a perfect score. Those who delivered in 7 days had a perfect score, because that delivery is within the perfect score range, which is 7 days. Okay. All right. Now that we have calculated our delivery timeliness index, we'll do the rest of the calculation in our spreadsheet. So let us load this to our spreadsheet as a table. Okay. So we'll go to home, click the drop down, close and load, and say close and load. So we have our supplier performance table successfully loaded with all the columns we added previously. So now here in our spreadsheet, let us calculate or create a true quality score. So let's create a column called true quality score. We hit enter and we'll be extending our table. Okay. All right, let us calculate our true quality score. So we'll be using this formula to calculate our true quality score. Let me share something. While this formula is arranged this way, sometimes if you put them, say, if we go ahead and insert them like this directly here, you'll find out that if you try that, you find out that it may not calculate well for you. So what I did was to write the formula in my notepad and copy it here so that it reads every part of the formula. And if you notice this at defect rate refers to our defect rate. You can see the highlighted cells. The compliance score here refers to our compliance score. Then the delivery time in days here refers to our delivery time in days. These cells are addressed like this because they are in tables, okay? They are in tables. That is why they are addressed this way instead of the normal K2, L2, and M2, okay? That is why they are addressed this way. So the at defect rate here refers to K2. The at compliance score here refers to L2. The delivery time in days here refers to M2. We have them this way because they are in a table. Let's hit enter to calculate this. Okay. All right. So let's do a manual walkthrough to explain this formula. A defect rate in percentage here refers to our defect rate column. And notice the parentheses. We will be dividing the value of our defect rate by 100 because we want to take off the percentage nature of our defect rate. The result of that division will be subtracted from 1. We are going to multiply that by the value we will get from dividing our compliance score by 100. Still, the reason we are dividing by 100 is because we have it at percentage. So if in your data set, you do not have defect rates in percentage or compliance score in percentage, there will be no need to normalize it this way. In your case, it may just be 0.6. So you will subtract 0.6 from 1 instead of going ahead to divide it by 100. Again, I'm emphasizing that we are dividing by 100 because we just want to normalize it to take it out from the percentage nature that we have it in our data set. The result from defect rate divided by 100 subtracted from 1 will be multiplied by the result of our compliance score divided by 100. The result of that multiplication will now be multiplied by 0.7. So that is the first component of the formula. The second component of this formula is the delivery time in days. We have the column delivery time in days. So our results from here will now be added to our first component, as you can see with the plus. Find more details of the breakdown of this formula, the description and explanations in the document attached in the description. So after that step, we have to normalize the cost and quantity, okay? So why do we have to normalize that? Suppliers have different cost and quantity scales. Normalization turns them into values between 0 and 1 so we can compare them fairly, okay? So let us normalize the cost. All right, for us to normalize the cost, we have to create name ranges, okay? And so let us name this new sheet or insert a new sheet and name it normalization. We are going to be using this normalization sheet to normalize our cost and quantity. So let's start with cost, okay? And we are going to have mean cost and max cost, okay? So in mean cost, we want to enter the following formula. So we will say equals mean. Mean here returns the smallest number in a set of values, okay? So say equals mean, and we'll go to our supplier performance table. We want to use our costs, okay? So we will click here, hold Control and Shift, and use our down arrow so that we can highlight everything within that column. We will close our parentheses and hit enter. Then we are going to get the smallest value within that range. For max cost, we'll say equals max. Max returns the largest value in a set of values. So it's going to return the largest value within our range. So that range, or the range we want, is in the supplier performance table and still within that cost per unit in USD. So the same way, highlight that, close your parentheses here, because remember you open the parentheses, right? And hit enter to give us our max cost. So we now need to define this. So let's have a defined name for this cell. So we are going to select this, right? Then we go to formulas. Then in name manager, we click name manager, and let's add new. It picked mean cost because mean cost is the label here, and refers to is correct here because it refers to normalization sheet. Then the cell which we highlighted, which is B2. Okay, so this is okay. Remember, the scope is to be applied in this workbook, so this is fine. Click OK, and we have named that range. Okay, let us add another for max cost. So say new. Now it is blank because we didn't highlight any. So we'll just call this max cost. Then in the refers to here, we will take this out and click the cell for which we want to refer to for max cost. And click OK. So we have mean cost and max cost. Let's close this and go back to our supplier performance. So we are going to add a new column in our supplier performance here, and that new column will be called normalized cost. So say normalized cost and hit enter to extend the table. In normalized cost now, we want to enter the following formula. We'll say equals cost in USD, that is cost per unit. This, right? Sorry, we're supposed to open a bracket because we are going to put this in bracket. That is open bracket, cost per unit in USD, that in reference to that column, our cost column. So minus our mean cost. Okay, this is it. The named range we created earlier, close parentheses. You see, that's why I say we have to open parentheses earlier. Divide by open parentheses, our max cost minus our mean cost. Okay, close parentheses. So what we mean here is that we want to subtract our mean cost from whatever we have as our cost. We want to divide that by the value from max cost subtracted from mean cost. So that is what we want to do here. We'll go ahead and hit enter. Cost column. So if a supplier has lowest cost, the result is 0. If a supplier has the highest cost, the result is 1, right? And you may want to look at this. Let's look at the cost here. You see that the max cost here is 49. Remember that. Okay, so the smaller the cost, the closer the normalized cost is to 0. The higher the cost, the closer the normalized cost is to 1. So that is what it means. So let us normalize quality. We'll go back to our normalization sheet, and now this will be the quality area. In the quality area, we want to say mean quality here, then here will be max quality. So we will still use the same formula, just apply to different columns. So we will say equals for mean quality, mean, to return the smallest value in the mean in the quality column. So we want to go to our supplier performance. Remember, we added true quality score earlier. So we are going to highlight all the values within our true quality column, then close our parentheses, okay? And hit enter. So the minimum quality we had was 51. Let's look at the maximum quality. We'll say equals max, open parentheses, go back to supplier performance. Let's look at the values within the true quality score again. Now close parentheses right in the formula bar here, and then hit enter. So this gives us our maximum quality. So we have to name this range again. Let's start with mean quality. We highlight this because that is where we want the range we want to name and refer to. Click name manager and let's create new one. So the label is mean quality, which is appropriate. The reference is B6, which is appropriate. We click OK. Let's add another. Another will be max quality. And the reference, instead of B6, will be B7. Then we click OK. We have max quality and mean quality. We click close. So let us use them here. So we are going to create a new column in our table called normalized quality. Normalized underscore quality. Hit enter to extend the table. So let us insert this formula. We'll say equals. Now is going to be the column we use, which is true quality score. I beg your pardon again. Let's open parentheses before we reference true quality score. Let's subtract mean quality using the mean quality name we created, close parentheses, divide by, open parentheses, max quality minus mean quality, close parentheses. So this is the same logic we use in normalized cost. 0 will mean the worst quality, while 1 will mean the best quality. And the closer it is to 0, the worse the quality. The closer it is to 1, the higher the quality. The next we will do is to build a composite supplier score. This composite supplier score will create a single performance metric that balances quality and cost to identify the best overall suppliers. This will help us identify the best overall suppliers, that is, those who deliver high quality at low cost. For us, that will be our recommendation. So let us add a new column called the composite score. So say composite score, hit enter. Let's insert this formula. We'll say equals 0.6 multiplied by our normalized quality minus 0.4, that is our normalized quality, minus 0.4 multiplied by our normalized cost. Let me explain this formula. Our normalized quality here is the normalized score of our quality score. That is our true quality score. Remember why we had to normalize them, to scale them from 0 to 1. Our normalized cost now is a column we got from our cost. We had to normalize it so that we scale them from 0 to 1. Now, 0.6 is the weight assigned to quality, meaning quality is more important in this evaluation. While 0.4 is the weight assigned to cost, meaning cost is important, but less so than quality. That is to say that your own range, probably the company or your clients may require something different. Theirs may be 50% quality and 50% cost. So it will be 0.5 multiplied by normalized quantity minus 0.5 multiplied by normalized cost. That is what yours may be. If your goal is a higher quality than 0.6, it may be 0.7, that is 70% quality and 30% cost. Remember, it's in the 100% range. So let us take this to 2 decimal places. That is our composite score to 2 decimal places. So we need to normalize this to a 0 to 100 range. We will have done that in one formula, but it will make it longer and difficult to understand. So let us add a new column called composite score 100, so that we'll know that this is for 100%. So let's use this formula. We'll say equals, open parentheses, composite score plus 0.4, close parentheses, multiply by 100. We hit enter to get our composite score in percentage. So you may ask, why the 0.4? For instance, look at this. A raw composite score of 0.19 may be too low. So adding 0.4 ensures the minimum possible scores becomes 40. For instance, come down here to 0.07, you can see what we mean. So there are scores that are way low, that if we let them, they will be too low. So we are just using 0.4 as a boost. So we are just using 0.4 as a baseline boost, okay? So that when we add 0.4, the minimum possible scores become, say, 40, right? Just like we have in 0.07. And so understanding this will help you explain to your stakeholders why we have this as a composite score 100 as to this as the composite score. If we were just to multiply this by 100, we are going to have 19% here. We are going to have 21%. This will be 8%. But if you look at this now, what we have done here in the composite score 100 kinds of bring this closer, right? Because you will see that our composite scores become closer. All right, now let's go ahead to define our quadrant logic. Okay, remember the quadrant we looked at during the introduction? Let us define the logic. So we are going to add a new column called cost score. So in cost score, what we want to do is to multiply our normalized cost by 100% or by 100. So equals our normalized cost multiplied by 100. So this is our normalized cost now multiplied by 100. Let us make this into 2 decimals places, okay? So we are going to add another called quality score. So quality score will be equals quality or normalized quality multiplied by 100. Hit enter, we have our quality score. So let us take this to 2 decimals places. So there we have it. This will help us now with our quadrant column. So let us add the quadrant column. We'll say supplier quadrant, hit enter to have that as part of the table. Okay. So we are going to use the ifs as well as the and to help us with this supplier quadrant. So let's insert this formula. We'll say equals ifs. So ifs check whether one or more conditions are met and return a value corresponding to the first true condition. We'll open our parentheses. So what is our first logic? And we will say and. Let us expand our formula bar to hit enter within your formula bar or cell without making Excel think you are done. You hold down alternate. So I'm going to hold down alternate here. After parentheses, I'll hold down alternate on my keyboard and hit enter. Open parentheses. Let's enter the first logic, which will be cost score less than or equal to 40, comma, quality score greater than or equal to 70. Close parentheses and say comma. Let's enter the value to return if this condition is true, and that will be best quality. Close our quote. Now, why we are using "and" here is so that we want to test these two conditions, and these two conditions must be met. And the first condition is that for us to have the best quality based on our segmentation, it means that price or cost of the product must be less than or equal to 40. Then the quality must be greater than or equal to 70%. That is for us to have that as best quality. So we'll say comma, hold and alternate again and hit enter. We'll say and. Let us enter another condition. You know, we have is a quadrant and we need to have 4, right? 4 sides. So we'll say and, open parenthesis, cost score less than or equal to 40, comma, quality score less than 70, close parenthesis. What would that be? Let's open quote. It will be cost optimized based on the categorization we are doing for our clients, close parenthesis. So what this means is that when cost score is less than or equal to 40 and quality is less than 70, let us say we are optimizing cost if you are going with this, right? Because quality here is not as quality in the first scenario here. In the first scenario, quality is greater than, that is, starts from 70 to 100. In this second scenario, quality is, say, less than 70, that is from 69 downwards. That is what this means. So let's hold down alternate again, hit enter to enter the third quadrant. So we'll say and, open parenthesis. So here we want to say cost score greater than 40, comma, quality score greater than or equal to 70, close parenthesis, we'll say comma. We want to say this is a cost risk. And why is it a cost risk? It is a cost risk because it's too expensive, isn't it? Because cost is greater than our 40 threshold, while quality is also high, as at best quality is high. So we'll say comma. Oh, sorry, we have to close this quote. If not, this will close quote instead of parenthesis, close quote here. All right. Then hold down alternate and hit enter again. We want to now say that is a fourth quadrant. So if all of these conditions are not met, there is one condition left, a reevaluate quadrant. So we'll say true, comma, open quote, we'll say re-evaluate, close quote. Hold down alternate, hit enter, and close our parentheses. Okay? So this will give us our quadrant. You can use this method to segment various things creatively so as well. Okay? And why do we have parentheses here and close parentheses? Is because we added and, okay, within the ifs. So we open parentheses to satisfy the and. If we come here, you see the logic. Once we are within and, we are satisfying the and logic, right? If you come outside the and, you see that you have gone back to the if logic. So that is how this works. So let's hit enter and you'll see what our output will be. So this is cost risk. This is for best value. Shall we see why this is cost risk? Score, that is cost score is greater than 40. Quality score is greater than what? 70. So this is where that lies. This is where this lies. For best quality, this is where that's satisfied. You see the cost score, that is cost score here, is less than 40. That is to say the cost is less than 40%, whereas the quality is greater than or equal to 70%. That is why we have best quality, satisfying this first part. Come to reevaluate, you see that cost is greater than 40%, while quality is less than our threshold of 70%. So you see that's why it's reevaluate, because why is cost higher than quality? So that is what this means, okay? So the next step will be to visualize our quadrant. And to visualize our quadrant, we need 3 columns. We need the quality score, a cost score, and our suppliers. So I'm going to take this back to Power Query so that I create or duplicate this supplier performance query so that I can have the supplier quadrant. I clicked anywhere within the table, go to data, and I want to take this from table or range back. So it's going to name it supplier 2. I want to rename this to supplier quadrant. This will just help me easily to deal with duplicating that table. So I need a supplier. I don't want the material type, cost per unit, volume, material group, processing. From here, let me just right click and say remove columns. What I just did was to hold down my shift and keep clicking on columns that I don't want. Okay, and remove. I don't want compliance, these. I don't want these columns. I don't want these as well. I just want 3 columns. So these are the 3 columns I want. My supplier ID, cost score, quality score. Okay. So these are just the 3 I want. I can just leave my supplier quadrant, even though I don't need it, but I just let it be there. So I'll load this back to Excel. So I have this loaded. So from here, I'm going to insert a chart to visualize a quadrant. So what is going to happen now is that I will highlight what I need, then go to insert. I want more charts. Okay, so I'll go to all charts, go to XY scatter, and I'm going to pick this scatter, okay, is already highlighting the cost score and quality score. That is the columns we highlighted. So let us take this. So we pick this and say, okay, so we have taken this, we have inserted our scatter chart. Now is the time to format the chart. So let us format the X and Y axis of this chart. So the X axis is going to be our cost score, and the Y axis is going to be our quality score. Okay. So let's click on this. We'll go to chart design. Under chart layouts, let's add chart elements. And the elements we'll be adding are axis titles. Okay, let's add for the Y axis. And we say the Y axis is quality score, right? So say quality score. We'll do that for the X axis as well. That will be the cost score, right? Okay, so let's take this chart title out. The chart is at 100 already here as well. So let's deal with these spaces. Okay, let's deal with this. So we are going to all right, click on this axis and say format axis, that's the X axis. And I want to change this maximum to 100 and hit enter. I'll do the same for the Y axis as well. Click and right click, format axis, and make this 100. I hit enter. So have that 100 by 100. Okay. So now we need to add the threshold lines. To add the threshold lines, we have to create for cost quality, that's a vertical line, and for the horizontal line. So what do I mean? I mean that we'll say for vertical, so we'll say vertical, we'll have here cost, we'll have here quality. So for the vertical line, our cost will be our minimum threshold, that is our threshold of 40, whereby quality here is going to be, for this 40, it will be 0 quality, for this will be 100, right? So then here we'll come to the horizontal, where costs will be 0 and 100, and where quality will be our 70 threshold. Okay, so let's use this to add lines. So let's add a vertical line here to this chart. So we right click on the chart area here and we'll say select data, click on select data, and here we want to click on add. We'll click on add, okay? So for the series name here, since it's a vertical line, right, we'll call that vertical line cost threshold. The X series will be the 4040, that is the cost. Our Y values will be the quality as usual, right? So come to Y here, take these out, and the Y will be our quality. We click OK. So let us add for our horizontal, which will be our quality threshold. So I'm going to click add. The series name, I'll call it quality threshold. For the x-axis, we want to select cost, right? Which is the 0 to 100. For the y-axis, we want to select 70 to 70, which we have here. All right, then we click OK. We click OK, so we are done with that. If you look at this now, you see the colors, right? Our cost threshold is gray. If you look at it, it's at 40, right? Our quality threshold is yellow and it's at 70, right? From the y-axis, okay? So what we are going to do is to make sure we can make this into a line. So click on this series and right-click on it. So let's go to change chart type. So change series chart type. We want to change series chart type here for the quality threshold, as well as the cost threshold. So they are all on scatter, right? So let's click the drop down on these and say scatter with straight lines. Then for quality threshold as well, we'll say scatter with straight line. So this will give us this line across. We'll click OK, and now we can see the lines. So we basically have now our quadrant, the 4 sections, 1, 2, 3, 4. All right. So we can change the color of these lines. When you just click on it, you can see the line here. Okay. Underline, you can say solid line, so that you change the color to maybe something you like, maybe red. Then you adjust the size if you like, change the dash type to dotted lines like this. Then you can see that we have these circles here, okay, which are the markers. So you can click on marker here to change the marker shade. You can decide to say no line, then go to fill and say no fill. You see that the marker is gone. You just have the line. So you can do the same for this, okay? For the line, you can leave it at yellow if you like, or change the color. Make it dotted lines, okay? Then you can remove the marker so that it doesn't seem like it's adding to the scores, okay? So for the markers, we'll say no fill, we'll say no line. Come to border and say no line. So we have that, so, okay? Let's expand this so that you see. So we already have our 4 quadrants, right? So we can easily just look at this now and look at suppliers who are at the quadrants, or classify them based on these quadrants. So let's label them. Remember, we said to this axis, this is a quality axis. As we go up, quality increases. This is the cost axis. As we go to the right, price or cost of the product increases. Okay? So that is what it is. So let us label them now. Let's go to insert and insert a text box, or we can do that from here under text. We'll draw the text box here, and let's call this best value. Best value. Reduce the font size to match our shape so that we don't cover any points. Let's make this shape, let's make it green, okay? Now, let us duplicate this to the top right corner. This top right corner will be cost risk. Why will it be cost risk? Let us make this yellow and answer the question why it will be cost risk. It will be cost risk because it's going to cost so much, but they have good quality, right? Because the quality is high, but the cost is higher than the threshold. So it's a risk for our clients to buy them, not for the sake of the quality alone, but not for the sake of the quality, but the price. It's over our clients' spending threshold. Okay, that's why it's cost risk. Okay, so here this quadrant will be cost optimized. And why is it cost optimized? If you look at this quadrant, we have low quality, right, and low cost. But again, we also have certain suppliers who are very close to the high quality margin. So it can be a risk to purchase from this segment, but we can reevaluate or evaluate quality based on defects to see if we can spend less and get quality that we can use. Definitely not from those within this side or the bottom quadrant, not from those within the bottom quadrant here or the bottom of the quadrant. The last is a reevaluate group. This group have high costs and low quality for whatever reasons that may be. So what do you think about this quadrant? You let us know what you think about it, where you think you can apply it, and what has this opened your eyes to. So welcome to the quality audit module, where we want to enhance trustworthiness of suppliers based on their audit. We want to check if they had audit issues in the past 12 months. We will flag abnormal defect rates. So we are going to create a normal defect, right? You know that defect exists. It may not have reached a rate where we will recommend that our clients abandon or reject products. So let us see if we have any supplier that will be outside our normal rate. Okay, so what we will do, we will go back to Power Query. We'll go to data and queries and connections. So we want to double click on this to go back to Power Query. So from here, we'll be grouping, right? We'll be grouping by material type. Okay, this material type. All right. So, but before we group, we will duplicate this supplier performance. Let's duplicate this and name this quality audit. Hit enter. So we have quality audits now. Let's group by material type. So we can either go to home and group by, or in transform, we'll click group by. So let's click group by here. And we already highlighted material type. So that's why material type is here. So on the operations, we want to click the drop down and say all rows. The column name, we'll call this column group data. We'll click OK. So we have material type and we have grouped data. So let us add a new column called normal range. Okay. So we'll go to add column, custom column, and call that custom column a normal range because we want to create a normal range. So let us impute this formula. We'll say let defects equal table dot column. This grouped data, let's double click to enter that, comma. Now we had the defect rate column, remember that defect where you have the defect rate you are referring to, remember how you have it. So here we have it as defect rate in percentage. That is what we have as our column name for that defect rate. Close parenthesis, comma, the third quartile, that is Q3, equals least dot percentile, open parenthesis, defect, comma, 0.75, close parenthesis, comma, the first quartile, that is Q1, equals least dot percentile, open parenthesis, defects. If you say let defects, right? Defects, comma, 0.25. Close parenthesis, comma, let's calculate the interquartile range. IQR equal quartile 3, that is Q3 minus Q1, comma, the upper limit equals Q3 plus 1.5 multiplied by interquartile range IQR in upper limits. Okay, so let us explain this formula. So the defects equal to table.column group data defect rates here extracts values from the column defect rates. Remember, when inputting this formula, I said, remember the name of the column where you have your defect rates. The name of our column with the defect rate is defect rate percentage in brackets, right? So that is why we have it so. Then Q3 here computes the third quartile or the 75th percentile of the defect list, this list, right? Then Q1 computes the first quartile or the 25th percentile of that list. That is here, the Q3, 75% of the data falls below this value. The Q1, 25% of the data falls below this value. Then we calculate the interquartile range, the IQR, where we subtract quartile 1 or the first quartile from the third quartile. Okay? So this calculates the interquartile range, the spread of the middle 50% of the data. So we are calculating the upper limit now as the third quartile plus 1.5 multiplied by the interquartile range. So this defines the upper outlier threshold. That is, any value above this limit is typically considered an outlier. So that is what this does. So let's click OK, and we will have our values. All right, now that we've calculated our normal range, let us expand this supplier data. So click the expand button. So now you see we have everything within that supplier performance table. So we will now pick what we want. We just want the supplier ID, right? The material type, we already have material type here. So I think that will be good for us there. We have, I think let's also pick the defect rates, okay? So we uncheck this and click OK. So we have the defect rate, the normal range, okay? And now the material type and supply ID. So we are going to move supply ID to the left. So we have supply ID, defect rate, material type, and normal range. So normal range as well should be close to, rather defect rate should be close to normal range. So we are going to move this here. Okay, so now we have supplier ID, material type, defect rate, then normal range. So we will be comparing the defect rate and the normal range. So whichever supplier have a defect rate higher than the normal range will be flagged off. Let us add a defect alert column. the goal is to flag suppliers with abnormal defects. So let's go to add column, add custom column, and this custom column, we'll call it defect alert. All right, defect alert. Okay, so let us do this. We'll say if defect rate, let us double click to enter that. If defect rate is greater than our normal range, double click to enter that. Then open quote, what should it be? Investigate, else, open quote, normal. So if defect rate is greater than normal range, then investigate, else normal. Okay. So we go ahead and click OK. So we'll have that our defect alert is normal. It's normal because normal range are all greater than our defect rate. So everything is in the normal space. Okay. So this shows us that all of our suppliers have defects in the normal range. Okay. So let us just load this, okay, to Excel, and this will help us. This will help us basically focus on the quadrant because we know that there is no supplier that have defects outside the normal range. So we will definitely then look at this squarely where we will focus on the cost versus quality. Okay. Welcome to the module for our 3D map geo-visualization, where we will test regional patterns and supplier risk. So we'll be inserting a 3D map. So to do so, let's go to 3D map in Excel. Let's just reduce this, reduce the formula bar here. So to insert a 3D map, let's go back to supplier performance where we have the city, country, latitude, and longitude, okay? So we can highlight these, then we go to insert, and we can see our 3D map. Click on the 3D map to insert the 3D map. So you can see the spots already because we highlighted that data. So all we need to do is to set our fields, okay? So since we have already highlighted the location, it set the location axis for us where we are using a latitude. If you pick on city, you are going to see, because we have the city and if you pick country, you are going to see that change. Then our latitude was based on the latitude of our country. You can pick longitude as well. It's going to be the same because we had longitude and latitude. Okay. Now, this is the field list. The field list because this is the items we have from that table, the supplier performance table. So we can take volume in kg here per supplier. We take it, click hold and drag it to add to, we added volume here to the height. Okay, so in category, let us take our composite score to category. Let's pick this composite score, drag it to category. So this is going to give us the color scales, okay? So now you see that we have different ways that what we fix here on the chart we presented. We have the visualization. This is the start column. This is the clustered column. This is the bubble. This is heat map, right? So if you click on each, you see the heat map. This is the bubble. You can use the bubble. And now the size of these is represented by the volume, right? You can see we use volume here, the volume of the supplies. Suppliers with the larger green colors indicates better composite score, right? So you can see the green and so on. So in the composite score here, in this map, Green represent high score composite, that is best value, yellow mid, and red risk. So you can see those, so that will help us as well. So you can close this to see this very well. Now, we just have this in this section of the map. In situations where you have it spread across, you can always move the map around the globe to see your visuals. Okay? Remember, we will get to a proper visualization class where we'll focus on visualizations properly. Now we are just solving problems. We are presenting the solutions to our problems in ways that insights can be derived. Okay? So you have a blessed day. Remember to practice.